We are moving on to quadratic functions and their graphs today. A quadratic function is any function that can be written in the standard form of y equals ax squared plus bx plus c, where a, b, and c are real numbers and a cannot equal 0. So if you notice, that is what we've been factoring the last few days in class. So you have already been working with quadratics, just not graphing them and finding their zeros and such. So a parabola is the graph of the quadratic function. It forms a U shape. And I put a couple of examples over here on the right-hand side of parabolas. And a parabola can do one of two things. For Algebra 1 here, it can open up or it can open down. So when it opens up, that means the a value is a positive number. So that coefficient in front of x squared is positive. Then you know that your graph is going to open up and actually look more like a U. If that number is negative, like a negative 5x squared, then you know it's going to open down and it's going to look more like this one right here. Okay, so that's how you tell the difference of which way they open. A vertex is the highest or lowest point on a parabola. It can be one or the other depending on how the parabola opens. If the parabola opens up, then the vertex is going to be the very lowest point. And if it opens down, then it's going to be the actual highest point. It's where the graph changes direction. A zero of a function is an x value that makes the function equal to 0. Or in other words, where the parabola crosses the x-axis. So we are going to be finding the zeros of these functions. That's what they mean when they say solve the function. They mean what are its zeros, where does it cross the x-axis. You can have no zeros. You can have a parabola that does not cross the x-axis, so there would be no solution. You can have a parabola that sits on the x-axis, so that means its vertex is on the x-axis. So there's only one answer, or you can have one that goes through it twice. So you could have two answers. And the axis of symmetry is a vertical line that divides the parabola into two symmetrical halves. So if you took the parabola and folded it in half, that line you create is going to be its axis of symmetry. Okay. So for example 1, we have solve y equals 2x squared plus 6x plus 2. So with your graphing calculators, you are going to hit the y equals button, and then you're going to type in 2x squared plus 6x plus 2, and then hit graph. And you will watch the calculator actually graph it. And then what you're looking for is where does this parabola cross the x-axis at. So I already have this one done here and typed in, oops, and I put 5 here and not 6. So let me change that. So as you can see, it crosses right here and it crosses right here. So this one actually has two answers. And if you use the Desmos calculator, graphing calculator on your computer, then you can just simply set your mouse on the points and it tells you the ordered pairs. So this answer is negative 2.618 and this one is negative 0.382. So you can go ahead and write those down for your two answers. You don't need to write the whole ordered pair, just the x value. Okay. If you're using a graphing calculator in class, once you hit graph, you can do one of two things. You can move your cursor over the graph and it tells you the coordinates at the bottom, or you can hit table and you can go through the table of points and figure out where your y is 0, then your x values would be your answers. All right, for this one is not in the form of y equals. So we have to make it in the form of y equals. So looking on the side where the y is, I have plus 6x. So I'm going to minus 6x from both sides. So they cancel here, and we have y equals, and I'm going to put them in order, x squared, then my minus 6x, and then a plus 9. And then we will move over to the graphing calculator and type that in over there. And then we can look at our graph. And I'm zooming in here. And where this one is only crossing one point, it's really not even crossing, it's sitting on, and it's sitting on right at 3. So this problem has one answer, and that answer is 3. And then our last example for the day is the height in feet of a basketball can be modeled by f of x equals negative 16x squared plus 32x, where x is the time in seconds after it is thrown. Find the basketball's maximum height at the time it takes the basketball to reach this height. Find how long the basketball is in the air. So there's 3 questions here. I need the maximum height, the time it takes the basketball to reach that height, and I need to know how long the basketball was in the air for. So let's start off by graphing this first. So negative 16x squared plus 32x. Here is my graph. If I zoom all the way out, it goes all the way up to there. So first question was maximum height. So it looks like the basketball goes up in the air to 16 and then starts to come back down. So if I go back over here, the maximum height that the basketball reached was 16, and it said this is in feet. So we know that's 16 feet. The time it took to get there would be our y value. So if I scroll back out, we're at 16. If I come straight down, right down here, we're here. The time it took would be our x value down here. So that looks like right in the middle would be 1. And time is in seconds. So this would be 1 second it took the basketball to reach 16 feet. And then how long was it in the air for total? If we go back and look at our graph, you can see it went up at 0, and the x-axis represents the ground. So it went up all the way up there, and then it comes back down and it hits the ground at 2. So it was in the air for a total of 2 seconds. 2 seconds in air.